stay safely at home. So yesterday I was discussing, the last topic was floating and sinking, but yesterday I could not perform better, actually I was not well. That's why that topic little bit I am repeating it. Okay. Now here you see, floating and sinking, first one what I said, then when a body is inside water, then two forces are acting on the body. What are the forces? Weight and upthrust. So you see, when weight is greater than upthrust, weight is acting downward, upthrust is acting upward, then what happens? So you see how I have drawn it. W I have drawn it by a bigger line and U small line. So weight greater than upthrust means density of the solid body greater than density of the liquid body. Alright. So what happens? The body will sink. So here you see where I have drawn the body. Body is sinking. Next one. When W equal to U means what is happening? Weight and upthrust they are equal. So when you draw the two lines representing W and U, make them equal in length. Then what you can say, density of the solid is density of the liquid, and in this case you see the body is floating but fully immersed, means entire body is within the liquid. Okay. Now third case, yesterday I did not discuss. So third one, it is little bit you may find it difficult, but if you understand not, it will difficult. So try to understand it. If weight is less than upthrust, clear, upthrust is more, then what will happen? Means what? Density of the solid is less than density of the liquid. Then what will happen? Just try to understand it. This diagram, whatever I am showing here, you don't have to draw. You will just write down these three steps as I have written. Okay. The explanation I am giving here, drawing the separate diagram, don't draw. And don't message that I have missed this, you will draw, no, this and that, don't ask. So here you see what is happening. First, upthrust is more. Alright. So upthrust is more than weight. So what will happen? The body will start rising up. Clear? Now, when the body start rising up, then slowly when the body will come out from water, then you see the volume of displaced water, it gets decreased. Alright. So when volume of displaced liquid it decreases, then upthrust also decreases. Then what happens? One time will come when upthrust and weight they will become equal. Got it? What I said? Initially upthrust is greater than weight. So upward force is more. The body is moving up. So in this way, when it will start coming out from the liquid, you just look at this, entire portion is not with the liquid. Then what is the volume of the liquid displaced? Volume of this portion. And initially, what was the volume of the liquid displaced? The entire volume. So what is happening? Volume of the displaced liquid decreases. Therefore, upthrust start decreasing. So when upthrust starts decreasing, then one time come when weight and upthrust they become equal and the body starts floating. But look at the diagram. The body starts floating partially submerged. Clear? And in this case, you see here what is W? W is total volume of the body multiplied by density of the solid multiplied by G. And whereas what is the upthrust in this case? Upthrust is small v. Small v means which portion? This portion. The portion of the body which is within the liquid, that volume is small v. Alright. Into density of liquid into G. Understood? So here you see density of the liquid is not changing, but what is happening? Volume of the body inside the liquid, it is decreasing. So upthrust decreasing, and one time will come when weight and upthrust will become equal and the body will float partially submerged. Alright. So I have underlined here. For this case it is floating fully immersed. Look at the diagram. And in this case it will float. In this case also it will float. But how it will float? It will float partially submerged. Alright. So these three cases, the way I have written, that one you must copy in the book copy in the notebook, but not that diagram. I have already rubbed that. Next is application of this concept of floating and sinking. Now you have seen that iron nail, you just take one iron nail and you put it in water, iron nail sinks. But the ships are made up of iron, but iron ship easily they float in water. Now the question is why? So if you consider iron nail, for iron nail, density of iron is greater than density of water. So weight of iron nail is greater than upthrust exerted by water on it, and as a result it sinks. Alright, we know what is the condition for sinking, weight greater than upthrust. Now for iron ship, I have written here point wise, okay. So first you listen to the explanation, elaborate explanation I will give, then that elaborate explanation you don't have to write, then just these 2 point wise you just write down the keywords that examiner wants. Alright, now for iron ship, you have seen the iron ship. Iron ship is made up of iron, but it is made very large in volume. Just you look at this, if you just draw the iron nail is like this, whereas iron ship they are very big and the shape is like this. Alright, so you see, as the volume is very big, so what it will do, it will displace a large amount of water. And you know, upthrust is what? I've already last class I said, upthrust is equal to volume of liquid displaced into density of liquid into G. I hope you can remember. So you see here, when the volume of liquid displaced increases, then what happened? Upthrust increases. Alright. So that's why the first point, if it comes that why iron ship, it is made up of iron but it floats. Then this is the way point wise you will write down the answer. That volume of the ship is made large, so it displaces a large amount of water, and that's why what happens, upthrust increases. Alright, here what was the problem? Weight was more than upthrust. Clear? That's why it was sinking. Now here what we are doing, we are increasing the upthrust. Clear? Then next point, inside the iron shape it is almost hollow, isn't it? Hollow means what? Air is there. So if you just find out the average density of air and the iron present within that, then due to this case that within the iron ship it is made hollow, what happens? Average density decreases. Now you know what is the weight of the iron ship. Weight of the iron ship is volume of the iron ship into density into G. So what we are doing here, you just see, we are decreasing the density. So you see what cleverly is done, upthrust is increased and weight is decreased, so that weight and upthrust they can balance each other, alright, and the iron ship can float. Okay, so what is happening, that ship is made hollow from inside, so average density of ship decreases. So these are the two causes that why iron ship can float in water. Now if you consider the floating of a ship, then in river water what happens? In river water the density of water is less. Alright, so as the density is less, so what happens? Upthrust is less, means what happens that in a ship it floats with more volume immersed within water in river water, as the density of river water is less. Now in sea what happens? The density of sea water is more due to several minerals and salt present within it. Density of the sea water is quite high. So as the density of sea water is quite high, so upthrust exerted by sea water on ship is also high. So what happens in sea, the ship it floats with weight is, upthrust is here, upthrust is more, weight is less, so with less volume immersed within the water, the ship generally float. Alright, so these are the two cases you must learn. Now, you consider one ship. So you see what is happening when a ship is sailing from river to sea. What will happen? When it will sail from river to sea, then it will come up. Okay, little volume means more volume will come up from the water. And if the opposite thing happens, means if the ship sails from sea to river, then what will happen? The moment it will enter into the river, then more portion of the ship, it will go within water. Alright, now what is the problem? If you consider the cargo ships, means the cargo ship which carry different materials from one country to other. Alright, the materials, it is sent from one country to other, not only by air, it is also sent through the ships. They are known as the cargo ships. Now when the cargo ships are loaded, then suppose the cargo ships is loaded in, just consider this example, don't have to draw the diagram. Just you consider that only the loading is done in such a manner. When it will load more and more, weight will increase, so it will go inside water. Now suppose one cargo ship is loaded like this, means a little bit is above water. Okay, now when it is sailing, when it is carrying loads, okay, materials from one country to other, then they go through different seas also, and in different seas also the density are different. Now suppose it happens that it has entered into a sea where the density of water is less, means upthrust is less. Then what will happen? It will sink more within the water. Then it may happen that fully it may go inside water and become Titanic. Alright, it will go inside water only. Clear? So that is the unwanted thing. So that's why what is done, that on the cargo ship, if you consider the body of the ship, then the body of the ship means outside. Suppose I am just drawing the diagram. Suppose this is the ship, then outside a white line is done. Okay, whenever you are loading the ship, then it is done this way. The moment this white line, it will touch the surface of water, then loading is stopped. Alright, why? If you do this, then what will happen? When the ship will travel from one sea to another, from sea to river, anywhere it will go, it will never sink. Okay, so this white reference line drawn on the body of the ship and which indicate the maximum depth to which the ship can be immersed within water is known as the plimsoll line. So whatever I have discussed elaborately, that point wise I have written here. You too in the copy write down point wise. So these are all the important points related with floating of iron ship. Now next topic is floating of an iceberg. Now for ice, what happened? Density of ice is less than density of water. Alright, now density of ice, as it is less than water, so weight of ice is less than upthrust exerted by water. Today only the third case I have already discussed. Then when upthrust is greater, then what happens? The body will rise up and then the body will float with partially submerged. So here you see, if you put a piece of ice within water, then the ice will float like this, partially submerged. Alright, not the entire portion within water. But for ice, the speciality is that 89.3% of the entire volume is within water, whereas 10.7% total volume is above water. What does it mean? A large portion of ice, it remains within water, only a small portion is visible. Alright, so that's why I hope you have seen the movie Titanic. Now why the Titanic what is the cause that Titanic sank down? Due to this fact that its iceberg collided, isn't it? So what is iceberg? The big pieces of ice floating in water, they are generally called as iceberg. Now for iceberg, the icebergs are very dangerous. They are threat for the sailing ship in the seas. Why? Because for iceberg, only a small portion is visible. Alright, so if you think that only a small portion are visible, so the size of the iceberg is very small, it may not be. It may happen that within water a large portion is there, that actual size of the iceberg is very large. So if the question comes on this topic, generally question comes on this topic like this, that why icebergs are dangerous for the ships, sailing ship in sea, then you have to write down the answer pointwise like this, that density of ice is less than density of water, therefore weight of ice is less than upthrust, and then you will write down this. If you can draw the diagram, well and good, otherwise you can write down in sentence only, therefore iceberg floats in water with a large portion within the water. That's why icebergs are dangerous for the sailing ship. Now swimming in sea water. Now already at this point I discussed that in sea water what happens, due to the presence of minerals, density of sea water is bigger than density of river water. So what will happen, upthrust exerted by sea water is more. So when we swim, then upthrust acting on our body helps us to keep ourselves above water and to swim. Okay, so what is happening, as the upthrust exerted by sea water is more, so it is easy to swim in sea water than in river water. So thank you girls. So these are all the important points of the physical quantities and measurement chapter. So you please learn the theory part, and within 1 or 2 days I will send you the answer of all the questions in the exercise through the PDF file. Okay, by the time you learn the entire chapter. Alright, point wise you must learn the entire chapter.